Good afternoon here in Nuremberg. I just arrived here from Austria. My name is Olaf Vögele. As Jürgen just said, I am one of the editors of the specialized magazine dealing with windows, facades, glass, and sun protection. And for 30 years, I am now an expert in this field, where we are, of course, confronted with these topics. Okay, of course, here it reads caution beware of overheating. I mean, of course, we do have wonderful windows, for instance, of vacuum glazing. This was a very interesting presentation. We have sun protection, we have controls. And in my presentation, I would like to show you that these things only work in combination. So not only one solution can save the world, we rather need a combination of all that. If we look at the trend with these wonderful large window panels and the floor to ceiling windows. Then what is also something that is coming are the blinds in between the two glass panels and smart home with the remote controls, which is not only applicable for windows and sun protection, but ideally also the heating, the light, ventilation, and so forth. Also, the comfort of use, for instance, for the garage entrances, which not is not necessarily energy saving. Of course, we do have a lot of savings potential with buildings. In Europe, approximately 40%, in Germany, approximately 36%, depending on the study that you are relating to. Here we have the development, the trajectory starting with the directive on heat protection and the Building Energy Act. I think that that is very difficult for this industry to have the right source of information, to have the right set of information. And I would say that the craftspeople are really very demanded and sometimes even overwhelmed. So I believe that something has to be done about that. The savings potentials, one third during winter, I can actually neglect that by simply providing an additional layer in front of the windows, for instance, in the form of blinds. What is much more interesting is two-thirds regarding the cooling demand or the overheating of the building. And here you can see windows and automated sun protection that, of course, should be controlled in winter and in summer alike, meaning that during summer I would like to have night cooling that can actually also store energy. Of course, during the winter months, I want to avoid that the building is cooled, and that's always the question. If it is, for instance, a blind that has to be operated manually or something that prevents the window from being opened or closed, then of course it is a problem. If, for instance, after work I go to the cinema or the theater and I get home at 11 p.m., if I don't have automated systems, everything is still open. I mean, of course, we are talking about windows with a high heat insulation, but if you have an additional measure, then of course it makes things much better and more comfortable. It doesn't need to be triple glazing all of the time. It's not only black and white, there are so many solutions in between. Also, out of cost reasons, it is not always the best solution to add something. I do not want to trigger a discussion regarding whether triple or double glazing is the right remedy. I think we would get a zillion different arguments for both embodiments, which is why let us just skip that and have a look at this slide. This is a slide that is provided by the IFT. On the one hand, we have the system variables that are predefined. This is everything that we can impact. On the other hand, you have everything that the user does. So this is where we do have an impact. And of course, we can then prove how effectively a system works. If we look at the topic of this event, namely the Green Deal and the CO2 efficiency of optimally attuned systems, I can tell you that the one on the right-hand side is certainly not what we claim in this forum. I just try to pick out a very blatant example. If, for instance, we go to China to the trade fair and we go to Shanghai, and if I say, okay, you give me €1 for every single a cooling system that I can see at the outer wall of the building, and it really looks like this picture. I never had to work again for just €1 for each of those boxes. The solution is rather having good windows combined with a good sun protection, and I cannot, select one product and call it the best of class. It always depends on the house. Something like the best sun protection does not exist. There is always an individual situation. It has to do with the sea level, with the direction orientation of the building, with all of the plans around the building and in the periphery. And here we see a study of the European Sun Protection Organization of the industry. And here you can say very clearly, if we had additional sun protection in the future, we can certainly reduce the volumes of the ventilation systems. And this is certainly one of the most important things, particularly in view of the energy expenses. The share of buildings that really need such ventilation system and how much we can save, namely electricity of approximately 870 terawatt hours. This is the energy consumption for Spain alone, and it is approximately 50 million people in Spain. So just put that before your inner eye and think about that. So we see this situation. We have Venetian blinds in this picture. We talk about thermal comfort. We talk about visual comfort. We also talk about sun protection, perhaps also glare protection, and also some sort of privacy protection because there are neighbors all around us. So I can just tell you that the Venetian blind sometimes might also be like provided with some sort of sound signal that gives off an alert if, for instance, somebody tries to break into your place. And how do we control all that? Well, we control that with the structure of the glass panels. We have the coating. This was also something that we've talked about, also the filling with different gases. Then also the control switch, which is exactly the same as bells for lifting the blinds. We have a remote control here, which only works when you're at home. So it might make sense in terms of comfort, but it is not automation because you still have to do something. You have to control it yourself. We have sun sensors. We are measuring the interior temperature, the outside temperature. We have smart home systems. So I would say that these are the small steps, the small solutions for your homes. And building automation, the big solutions for hospitals, schools, and big office buildings with 2,000 to 3,000 windows. And in most cases, what is missing is the integration of the automated ventilation. We do have ventilation systems ever since 1946. They are somewhere there in the walls. They have their own switches. They have the temperature sensors that are really working completely independent from the sun protection, but it doesn't really make sense. Of course, we have the manual ventilation by simply opening the window or tilting it at least. We have different windows with different U values. And if I, for instance, look at some new buildings, 20 buildings, and in every building there is one family with a small kid, then the door is open, and then the balcony door is open. And over the day, all of the windows are opened as well. So the U value does not mean a thing, except that I'm working with somebody who is passive house savvy and is really closing all of the windows the minute that the sun comes out. So you can see there is reasonable and unreasonable behavior. I have a couple of different drafts, particularly when it comes to those rooftop windows. For instance, if I live in the sub-basement, again, I can actually try to ventilate it naturally. And if I see a ventilation concept, here is a ventilation concept as well. Where is the window? Where is the sun protection? I mean, all of it is here, integrated somewhere. So I've actually fulfilled all of my tasks. I've provided for everything that was needed, and I've invested a lot of money, but I will not get the result that I could get And I've experienced that myself because of Corona, I spent a lot of time at home in the past 2 years, and our house is fitted with when you're equipped with smart home for approximately 98%. And now we've actually made it last summer to improve the interior temperature by reducing it by 7 degrees Celsius without changing anything about the mechanics of blinds or anything else, only based on the automated window systems, also the supply air, and we have a minus of 7 degrees, which makes it very comfortable in our house while it is hot outside. All of those areas are communicating actively with the sun protection, with the sun shields. And the question is whether the ventilation concepts will suffice with all of the air exchange rates in order to avoid the heat in summer. Because in summer, it is not 6 times 8 times 12. It is only about trying to exchange the air as quickly as possible in order to get the right temperatures in the house, particularly the heat that is stored in furniture and in other like surfaces. So, what can we do against heat accumulation? We control the sun in new buildings, in retrofitted buildings, and we are measuring in the units kilolux and wind meters per second. If, for instance, with the Venetian blinds, it is 12 to 14 meters, or the zip system, this is when you have to lift all of those shields. How do we measure it? With a wind sensor. It is a combination of wind sensors, outside temperature, frost protection, and other parameters. And now let's have a look at this chart here, how to translate lightness with the sun and how the controls react to it. So typical values would be a bright summer day, 70,000 lux. So most people are actually setting 30,000 lux in order to have the shields operated. So here you can see 20 kilolux as a cloudy summer day. Okay. As soon as the clouds appear, all of the sun shields are removed again automatically. Then shadow in summer, still 10,000 lux. It's still bright. Then if it's a cloudy winter day, it's 3 kilolux. Then at room lighting, 800 lux, and the street lighting, 10 lux or 20 or perhaps 25, depending on which operating system is used, LEDs or any other. And if we now look at a building with an annual shading program, here, for instance, you can see this corner that is taken as a reference point. So here we have this window number 13. Do you see that? I've marked it. And based on the astronomical calendar, for this window number 13, I can tell you for every single day when exactly it will be exposed to the sun. So when is the sun shining on window 13? And I could actually do that for the next hundreds of thousands of years based on the astronomical calendar. However, if we ask ourselves whether we measure in the right unit, is kilolux really the right unit in order to measure the heating in the house? This is something that I've also sort of disregarded until last year. But ever since last year, I'm dealing with the question of getting a photovoltaic system, which has changed my mind. Because let's have a look. This is PV. Here you can see the energy input of the global radiation. In Germany, in the north of Germany, very modest. If you are somewhere below Frankfurt, where I live, Heilbronn, things are getting more interesting. If you go to Spain, Italy, then of course it's getting even more interesting. Africa, of utmost interest and significance. But what is decisive here? In Germany, the median of the global radiation is 133.67 watts per square meter, which is tantamount to 1,171 kilowatt hours per square meter as annual overall quantity. In Spain, it's 230, so they have 100 watts per square meter per hour more than we. Now the question is, what shall we do? I've already shown you this picture. We are measuring the temperature, the rain, the wind, and the brightness in Klux. Now we have different devices, a pyranometer. They are actually measuring the global radiation. So they are at the moment not necessarily used to a large extent because they are so expensive. But if we look at this, you can see the global radiation, you can see how many watts you will actually gain. And if, for instance, you sit in your place, we had this wonderful audit only recently with Johnson Control, and they are not measuring in kilolux. They are actually measuring in global radiation. In the morning, 10 a.m., cloudy skies, 200 watts global radiation. So it is less than 10,000 lux. What would we do? We would lift our sun protection. They start measuring in the morning at 6 a.m. So it might be that at 6:30, when the sun protection or the shields or the blinds go down, it's a hot summer day, because energy is protruding into the building that we do not even see at that very moment because it's not yet that hot. If at 11 a.m. the heat is really burning down on our windows, then we will notice it, but it will be too late because we were too late in putting down our sun shields. If, for instance, you are somewhere on the mountainsides, a glacier, you don't see the sun, but still you are sunburned. Why? Because of the global radiation. So in our heads, something and somehow it is anchored that sun is tantamount to brightness. Brightness means warmth. This is a conclusion that is not necessarily wrong. It does work to some extent, but not good enough. Which is why I can tell you very clearly in this respect that if you look at the global radiation that actually hits the earth in this way, and here you can see a typical roof window, and that's very unfortunate if it is a window that is vertically built into, or sorry, horizontally integrated into a rooftop. It is exactly the same as with those that are vertically integrated. And if you are spending time in an attic or in under the rooftop, then of course you know why Velux is selling so many things that can be used up there. And nobody will ask you whether there is any alternative. You really need to do something about it, which is why there are so many different windows with blinds, with the solar units up there. So the inclination and the position of the window is the decisive component. Thinking things further with the global radiation, you have the direct one. You can see that here it is the radiation that hits the Earth unfiltered. So on days with the blue sky without any clouds, we have a reduced global radiation if, for instance, it is cloudy, if it's raining, if there is something that sort of hinders the sun. I have a rather diffuse light, I would say. In the third and the second case, I would say that sun protection would be lifted, otherwise it would be closed. But with that, we would be actually exposed to the radiation. If we talk about such exposure, we can see that the daylight control is also subject to subsidization. And here we can see a combination of the global radiation measured and the brightness of the daylight, because of course we would like to feel comfortable visually as well. We can decide for ourselves how much are we prepared to endure. What is my limit? What are my wife's limit? Everyone has a different sense. Everyone has a different sensitivity. Of course, if I just put down all of the blinds, it might be the best solution. It's like driving a car. Perhaps I am just, going faster and I risk spending more fuel, but I feel that it is worth it. Then it is exactly the same in a house. And if I look at the daylight situation, and I don't want to really read all of those bullet points here, but it is quite obvious that daylight and sunlight is helping people when you're ill, when you go to school, when it comes to concentration, when it comes to the performance of your stuff, sunlight and daylight is a positive thing. The Federal Association has actually presented a very good approach. Here they said that are no longer experts for sun protection, but now it is experts for heat protection. So I believe that this is an approach that is absolutely right, but you have to be consistent enough because if we talk about heat here, it is no longer possible to measure in those luxes, but rather in a different unit in order to be able to interpret it accordingly. In the magazine Glasswelt, I've just recently published an article on the question whether we are measuring in the right unit. So I'm very excited to get some feedback. There will certainly be somebody who will complain about my ideas, but I believe that this is food for thought. Then subsidization. So how can you be subsidized? Of course, implementing or integrating new windows, and then also replacement of sun protection installations with optimized daylight supply. And this is something that only works if the sun protection is automated. Only then will it be possible to like perpetually have it optimized and to sort of respond to the sun radiation in that some lamellae are opened or blades are opened. So here you can see the two boxes that are of importance. And if I then talk this topic further, this is one of the subsidizations that most people are not familiar with from the Federal Ministry for Environment, Natural Protection, Nuclear Safety and Consumer Protection. This is a subsidy for climate adaptations in social facilities. This is not only sun protection, it's also ventilation and the windows. And if you look into these papers here, it is about providing the staff members in those social facilities as well as vulnerable target groups, such as the elderly, ill people, children in kindergartens are protected against the sun exposure or the heat exposure. It sounds very complicated, but it is rather straightforward, and it is something that is well accepted for homes for the elderly, for hospitals, and so forth, care homes. And on the other hand, also for instance, for sun sails in kindergartens, sunscreens, lamellae rooftops. Here, for instance, the canteen of hospital that shows some sort of extended living room. This is something that is not being subsidized because they only subsidize the vertical sun protection because they say this is energy efficient. Here it is about the protection of people, which is why I believe it is a very interesting thing. All the requirements can actually be fulfilled, all the requirements that we need. At the end of the day, we need to join forces in order to get a positive impact. Currently, we are also trying to achieve an adjustable top value of sun protection. As you can see here, I can allow the transportation of daylight. The Venetian blinds are a perfect product for that. And don't want to talk about any producers, but this is like one of the types that makes sense. So the Venetian blinds, from my perspective, is the best possible sun protection because all of the parameters can be set. And this is not possible with the zip or with the blind. I mean, it does work if you don't have any alternative. But if you are planning something like that up until the height where it is possible, of course, there are limitations regarding the height of the buildings. But as I said, those Venetian blinds are certainly a very good solution. We also have to consider that for many buildings, some other things are not feasible. You can also talk about other glass types. From my point of view, excludes sun protection glass panels because the daylight is excluded. So this is something that I really like discussing also in public, also with respect to my colleagues from this magazine Glasswelt. So I can tell you we have fierce discussions, but still, I've already described it and you've seen the bullet points. It is actually enabling us to live and work in better in a better environment, in better surroundings, and the decision and selection criteria are really depending on the situation and cannot be generalized. The user of all that needs to live with it because unfortunately he or she is not only to a small extent involved in the planning process because they will not get any explanations as to what it is all about. And very often it is a pain point when you hear what went wrong for a lot of money and how much it costs to really get that rectified, even for the best architects, people who are not involved and not familiar in physical properties and physical requirements. That's, of course, a big issue because this architect will never live in the house. He has constructed it and built it. And then you have a user sitting in their house for 4 million euros and they have to spend some 300,000 euros in order to get all of the automated controls in place. Well, the consequence of many of those things can be seen in office buildings. You can see that there are some staff members who are really, you know, rebellious about those systems. They don't want to live with it. They don't understand why the sun blinds and the sun protection is lifted all of a sudden. Perhaps this facade is somehow coupled to another facade, and one facade is exposed to wind, and then there is a wind sensor, and the facade tells the other facade, okay, there's wind, lift the sun protection. I mean, there is a lot of work to be done in this respect. I can't tell you that one system fits it all does not exist. I have to look into the behavior of the building. It can change once that it is really fully occupied or once that the sun exposure is different. So it is really a huge difference between these systems integrated in a building. And it seems as if people don't understand that during summer there are leaves on a tree and during winter there are not. And that's exactly the same with such buildings, only because they were not properly explained. And the conclusion of an expert is that people are not sufficiently informed, and I'd say up to 90 or even 95% in all cases, the combination with the ventilation was not properly planned. The ventilation is there, but it is not integrated into the concept. And I can remember the 1980s where everyone had a satellite TV and a video recorder and like 7 different remote controls on their tables. Now they have 7 apps on their mobile phones. So actually, nothing has changed. We still have this overarching system. Perhaps you have Apple Home or any Android system. Perhaps they will replace those 7 apps. But I think that we are far away from that. Everyone does his or her own little thing. And when I run around this trade fair, there will be like 20 different apps which have one thing in common. And this is the positive aspect about it, that they all work with Alexa. So they all have voice control. And yeah, that's basically it. The users are at a loss for understanding. They are not satisfied. They don't feel like living in this house. And the practice shows us very clearly and very quickly that something that is regarded as a tiny little detail that gives us a lot of pain point. And I know many different cases where the architect, or rather his insurance, had to reimburse the expenses that were incurred in order to have a building that is fit for use. I mean, everything is right there on the paper. You need to have some protection, and at the end of the day, everything needs to work properly. How exactly is not stipulated, but I need to find a way to get there. And I can tell you that all of the means required to this end are available. And if there is like a well thought of sun protection that is adjusting to the external conditions, well, these are the variations that are possible. And practice showed here, for instance, in a Dutch study, that there is a lot of savings potential whenever the window and the sun protection cooperate, when they work together. And I don't have a study to show ventilation and how ventilation comes into play, but I wasn't able to find one. Do you know one? Do you know a ventilation study, what exactly we need? I'd say that this is something that we urgently need. Also, like in the context of control units, because we need to deal with this new way of controlling And we also have to measure global radiation, as I said before. So photovoltaics do exactly the same thing. They are just measuring what comes in, so to speak, what is the input. If you see those solar systems with the smaller surfaces, they are just as effective as a big rooftop because they are sort of tilting toward the sun like a sunflower. And I've seen that only recently during my vacations near a lake in Austria. And I passed by several times just to see how it works. And this is like a perfect alignment. And these are the things that we need to deal with. And I can give you a good recommendation. Please do not plan to in a way that many people would plan regarding a printer, because at the end of the day, you will be astounded to see how much the ink costs, and these costs are really huge because most people are not taking into account the life cycle of the building. They don't look into the running costs of the building. Today, it's energy with the huge energy prices. We don't need to discuss it. I think it is obvious for everyone that this is what makes a building more and more expensive if you look at it from an average of 50 years. So I believe that in some years' time, it will not reach 50%, but rather 57 or 58 or 60%. So I believe that it is a complete rubbish to look into the current planning approaches. This is how I earn my money. And I think there is a lot remains that can still be analyzed. Thank you for your attention.